So, can I go back to separation of variables technique? Matter of fact, looking at some population models, you guys have heard this all the time. Your entire mathematical career, you kept hearing some math professor or high school math teacher saying, populations grow in such a way that they increase at a rate which is proportional to how many members are present. Makes a lot of sense. If I've got a group of rabbits in my garage, and these rabbits double every month, and I just got myself 10 rabbits, and how many more rabbits do I have next month? How many more? The population doubles every month. Well, if I start with 10, then how many more will I have next month?
20.
Well, I have 20, but I'll have 10 more. 10 more, correct?
Oh, yeah.
Okay, so I think that the increase in my population is going to be 10 rabbits. Oy, oy, oy. What if I decide to get 100 rabbits? How many more will I have next month?
100 more.
Yeah, so I think the increase of 100 rabbits is proportional to how many rabbits I had initially. I think that equation makes perfect sense in many instances. However, if my population of rabbits doesn't grow in that fashion, then I think to find out what my population model is, I'll separate variables. You guys, relax. This is not a game of tricking you with or anything. I'm just straightforwardly going to solve this particular separable differential equation. It's a piece of cake. You tell me it's not. And be honest.
Yeah, you need Casey.
Well, in my world of mathematics, symbols conveniently disappear sometimes. Math magic. You guys know tricks. Okay. Oh, by the way, as long as A is a nice, clean, positive constant, which it should be because it's the initial population, and let's suppose K is positive, isn't this a strictly increasing function? Yeah. As a matter of fact, Y is increasing exponentially. And if I start off with 10 rabbits that double every month, do you think it's possible that when I open my garage after 2 years, puff, all these rabbits are going to be popping out? What do you mean?
They'll be dead.
They gotta be what? They gotta be fed. I don't make enough money to feed that many rabbits. Even if I did, certainly the environment is going to be too small, too constrained for them. And I think eventually with that many rabbits, even if I could feed them, there's going to be epidemic or disease taking over, and I think the population is not going to be increased without bound. As a matter of fact, I maintain with my particular finances and with my particular limitations of the physical constraints of my garage, I think there's probably some number out there that's an upper bound for how many rabbits I can possibly have survive in my garage. I got a name for that. I call it my carrying capacity. So maybe it is true. Actually, I shouldn't say maybe. It is true in many instances. My populations initially grow exponentially. It's just that if there's some kind of carrying capacity, I think sooner or later my population is going to level off. Do you guys agree with that? And I think if there is a carrying capacity, the closer the population value is to it, then what's happening to the rate of growth? It's going to what number? I think the rate of growth is going to go to 0. And so do you think maybe instead you and I can take this mathematical model and modify it? Like I said, I'm happy with the assumption that at least initially the rate of change in my population should be proportional to how many members of the population are present. I like that. I also, however, want to modify this DE by suggesting that maybe as my population gets closer and closer to the carrying capacity, my dy dx should be equal to 0. And I think introducing this factor where L is the carrying capacity does just that. After all, if I was really, really, really close to the carrying capacity L, that factor is really, really close to 0, forcing dy dx to be really, really close to 0 as well. You guys, can I change something here? Can I change these to t's, not x's? Not that this is a dramatic issue, but I am talking about population models. I like to be nice and clean. Besides that, don't you guys see I've already made a mistake? I was already assuming it was dy dt anyways. Not that it's a big deal. I'm just changing the letter variable. Well, everybody, I think that's a DE. That's a better population model describing populations with carrying capacities. And so maybe you and I should take a moment to actually solve that DE. Can I say this? This DE is so important, I give it a name. I refer to this as my logistics differential equation. And it's so much more realistic and applicable than that over there. Actually, I misspoke. I don't want to solve it yet. Can I do something different? Let's talk about that differential equation. And let's talk about dy dt graphed against y. What's that graph look like? I can ask it again. What's that graph look like? I can ask it a third time. Yes, sir.
Well, it kind of looks like an exponential first.
Does
So it's the,
I think you're going ahead of me. You're looking at, that's okay, you're looking at y as a function of t. I'm asking you something much more simplistic. What's the graphical relationship between dy dt and y? It's big math D. It's parabolic. After all, think of the y as an x. Think of dy dt as a y. Isn't that a quadratic function? Oh, but shoot, it's already factored. And it's already factored. Somebody tell me what the y-intercepts are in that picture. 0 and L. And I think, graphically speaking, my parabola looks something like this. Do you guys agree? Do you guys agree? Oh, I violated the vertical line test. It doesn't look like a function. You're right. Maybe too sloppy. I think I'm way off. Because I think with parabolas, there's going to be some kind of symmetry. And if there's going to be some kind of symmetry, let me think of my picture. I think if k is positive, it certainly will be a parabola opening downwards. Because y squared has a negative coefficient, I think it looks something like this. Now, because one of the y-intercepts, that's the horizontal y-axis, one of the y-intercepts is 0, you guys are free. Tell me what population value will maximize the rate of change in my population. Very nice. But that means if I go to the function y in terms of t, which I have not generated yet, I think I'm going to have an inflection point there. So I think at half the carrying capacity, I think the rate of change is maximized. Not that I've solved the DE yet, but I really want to solve it. So let's do just that. I'll get rid of all this. Let's solve. This differential equation do you guys mind if I make some assumptions? Just to clean up my notation. Do you mind if I just assume that the initial population's, I gotta make up some symbol. How about y symbol? Now in solving this DE, you guys, no offense, you'll be so much better at the end of next week. So no offense, as of today, you've only got one sophisticated technique in your back pocket. It's called separation of variables technique. So let me apply the separation of variables technique. And applying it, I see that 1 over y times L minus y, dy is an integral, is equal to my, I don't know, is that a k dt? And if I were to anti-differentiate on the right-hand side, then life is an absolute boring piece of cake. On the left-hand side, I will what was it? My pen's drawing out. Partial fraction decomposition. And so you guys want to pull out a scratch paper, or can we do it in our heads?
Scratch paper.
Really? You guys can't do that one off the top of your head? Anybody? Oh, come on.
A.
1 over L.
Huh? Why didn't you put A and B?
Oh, all right. Don't listen to me. Jeepers. I'll take a break. I'll pull out, where are you going to do this? Piece of crap here, right here.
It's easy if you have a computer in your brain, but
It's just playing with numbers. If I took 1 over this, by the way, keep in mind, L is just a constant, and try to break it up this way.
okay.
Clear my fractions. Take a break. Set y equal to 0. Doesn't that necessarily mean that, I don't know, is that a is equal to, I'm so tired. Is that negative?
1 over L.
Or positive 1 over L. But if I allow my y to be the other 0, which is positive L, doesn't that just simply mean that b is equal to 1 over L? So I was right after all, wasn't I?
Mm-hmm.
Shoot, I forgot. What's the whole point of this partial fraction decomposition? Integrate piece of cake. After all, I think with that first integral, this is nothing more than natural log of the absolute value of y. Oh, times that coefficient up front. That's not the coefficient, but this is. And with the second integral, you guys, I'm hearing my voice too much.
Minus 1 over L times the natural log of the absolute value of L minus y.
Looks nice. Equals kt plus c. But you guys, if I really can, if it's at all possible, I'd like to isolate y and to express y as a function of t, again, if it's possible. Not that it always is, using the separation of variables technique. But this time around, I think it is. You guys, use your hands, massage algebraically. So 1 over, oh, you said multiply by L? I'll do it your way.
Combine the natural logs.
I like that.
And combine C and L into one.
And I'll do the
variable.
division. I'll do it eventually.
Exponentiate.
I would.
Is the left-hand side ever equal to anything negative?
You know, I'm kind of nervous. I don't know if it might be the case that I really can't handle more than 200 rabbits in my garage. But the federal government's on my case. And they made the decision not knowing about my garage, and they're forcing me to put 300 rabbits in my garage. And so I think initially my population is going to plummet because the people in charge didn't know what they were doing. Next. I just want to tell them next.
Remove absolute values.
Very nice. Okay, you guys, my arm's getting tired. I'm writing too much. I'm wasting ink. At this stage of the game, do you mind if I just replace this garbage with another symbol?
For A.
Yeah, I'll use the letter A. You can use whatever you like. I'm being goofy, you guys. I'm just simply suggesting that it's all just a constant out front, where, of course, what I'm really suggesting is that A is just simply another name for plus or minus e to the CL.
So it's a good idea to just kind of leave it in that form until you get to the end and then replace it with a new constant? Or?
Yeah, you know, otherwise you're just going to keep replacing with something
Okay.
else. There's nothing wrong with that, Bradley. I'm just saying I'm lazy.
Okay.
And I got limited board space. That being the case, actually, do you guys mind if I take a break? Because I'm getting nervous with some of these constants. You know, technically speaking, the constant k up here in my first example is fundamentally important. I sometimes refer to that as my relative growth rate. So these constant proportionality, I think, are inherently attributed to the population itself and the other qualities of the population. I think L is fundamentally important. That's my carrying capacity. I think with my algebraic manipulation so far, A is not important the way you see it. Can't relate A to anything. So I'm going to take a break. And taking a break, if it is the case that y value 0 is equal to this constant y sub naught, which is the initial population, then take a peek at what I can say. I can say, with this equation, plugging y sub naught in for y, and simultaneously substituting 0 in for t, no matter what k and l are, isn't that just simply going to give me a? So, allow me to rewrite. In rewriting, I see that y over L minus y is nothing more than my A times e to the, is that KLT power? Shoot, guys, I just lost track of what I'm trying to do. What am I trying to find? I'm trying to find y. I'm trying to solve for y and get it as a function in t, if at all possible. But I see y twice. I'm not happy. Because I see y twice, let's try to see it only once. I think it's difficult because it's upstairs and downstairs within a fraction. So if you guys don't mind, I will get rid of fractions. And in getting rid of fractions, I see that y is nothing more than L minus y times y sub naught over stuff times e to the KLT power. You guys, I'm using my red pen because I want to isolate the red beast. That's my algebraic responsibility at this point. So solving for the red y, let's just do it. Ouch, shoot, this is kind of nice. This isn't math B, it's math A. After all, y is being raised to only the first power. I think if you treat everything else as a constant, this is a linear equation in y. And so I'm just going to bring all the terms involving y to one side. Shoot, I can't do that. I don't see what terms involve it. I guess I better get rid of parentheses. I do. I see that y is equal to y sub naught L over L minus y sub naught times e stuff minus y sub naught over L minus y sub naught times e stuff times the red y. So when I add this term to both sides, I do indeed have two terms involved in the variable y, and here they are. And on the right-hand side of the equation, oh, I just got that lingering term that I wasn't dealing with. You guys, are my math skills okay? I'm running out of ink space. I'm running out of ink space. Can I just put a couple algebraic steps in at once? So I went ahead in number one, factored out a red y from both the terms on the left-hand side. In number two, divided both sides by what the heck was being multiplied to. Wouldn't I just simply get the ratio of what you see on the right-hand side? Over 1 plus that term. Oh no, you guys. Shoot, I still don't like it. Darn it. It's got too many fractions embedded in the big one. So let's try to clean it up with our math skills by multiplying top and bottom by. But that merely gives me, if I can do this, that merely gives me that y is equal to my y sub naught L times e to the LKT power all over my L minus y sub naught plus my y sub naught e to the LKT power. Shoot. You know what? I still don't like it. I see e's too many times. So to force myself to see e only once, what can I do? Multiply top and bottom by. Thank you. 1 over e to that power. Or how about just multiplying top and bottom by e to the negative of that power? Same thing. And I think what I'm left with is that y as a function in time t could be interpreted as a ratio of this product to the sum of this product with my y sub, isn't there a y sub naught? My goodness. My subscript became a superscript. Sorry. You guys, I just did too much on the board. I might have made a mistake. Can we just check it real quick? Just real quick. Not a lot of work. I'll close my pens. Let's see what happens if t is equal to 0. And if t is equal to 0, I get e to 0 power here. E to 0 is 1. Now remove the parentheses. L minus y sub naught plus y sub naught is L. L's cancel, I'm left with y sub naught, which is the initial population. That's okay. Let's see what happens in the long run as t increases that bound. Assuming L and K are positive, as t increases that bound, don't I get right here a factor of e raised to power, which is decreasing with that bound? But that factor goes to 0. I'm just left with this ratio, which is
L.
L. Oh, thank goodness, this makes sense. Because I think my population model should, graphically speaking, behave in that fashion. If here's my horizontal t-axis, here's my y-axis, I think what's happening is my population initially is something. I think I've got a carrying capacity located with a horizontal axis, but wide as L. I think initially my population is growing exponentially, but sooner or later, I'm going to change concavity and hub arbitrarily close to that carrying capacity. And at what value of t is the rate of growth going to be maximized? I have no clue. But I do know that inflection point occurs at half the carrying capacity in terms of y values. We've already justified that. Wow, you guys, this is so important. Can I give it a name? That's my solution to the logistics differential equation. Or how about this? That's my logistics function that mathematically models populations with such carrying capacities. Now you have to admit, you guys, on the ink board, I've done two things. I've applied our first simple, basic technique of solving differential equation, which is separation of variables. And number two, I merely applied my algebra skills to isolate y completely in a coherent and simplified fashion. And you're so quiet. Does that mean you don't agree with me? Okay.
Can you
Like that.
can you quickly explain
Yes, I'll do whatever
how
you
you
want.
set up the top equation there? I'm
Up here.
yeah,
You know,
I'm
Brad,
kind of.
all I really was this. Let me backtrack on my word sorry. Are you okay with that?
Yes.
Now, I admit, once I got here, I took a break. And I said, I can find the value for A in terms of something meaningful.
Yeah.
But
I
then I
see that.
replaced that A with that fraction. That's exactly what that was. I think this line is that line with A being replaced with L.
Okay. Okay.
And then I kind of ran amok by saying, oh, well, let's call this Y here and this Y here a red Y, and let's isolate it. And so I think everything else is nothing more than a game of math D business in isolation.
I see what you did.
So does by extension that mean that the fraction that you replaced A with equal to what you replaced with A, the plus or minus the exponent of C times out?
No, that's true. You know, you could have viewed this Alice in an alternative fashion. You could have said, what I'm really doing is letting this thing right here be equal to, I forget what it is.
Back there.
Thank you. Plus or minus e to the CO power. I agree completely. I was just being more simplistic. I made a substitution first, just so this looks nice. I didn't have to. I could have easily done it the other way around. Anybody else want to shake me up on this before I get rid of it? Okay. All right. That means I feel comfortable getting rid of it.
Okay.
Shoot, it's the last day of the first week of class. I guess I better start a list.
Is there a Saturday meeting this week?
Can't be. It's not because it's the first week, you guys, but remember how I mentioned if you want to meet on Saturdays, we can. It just so happens this Saturday I've got something down at Sacramento Convention. Not mine, for one of our children.
Okay.
I'm just not around all day Saturday, so I'm sorry. But if you guys are interested, you let me know next week. If you want to do it next week, that's fine. And every week thereafter. It's up to you. So techniques for solving first order differential equations. Our first technique. Separation of variables. Now the separation of variables technique was a technique applied to a DE that was separable, and a differential equation is separable if it can be expressed in the form y prime is equal to the product of two functions, one of which is a function solely in x, and the other is a function solely in terms of the variable y. That's how I classify a DE as being separable, and you and I have discussed a technique of separation of variables for such DEs. Can I discuss a whole nother type of differential equation of first order? How about a first order linear differential equation? And I will subclassify a first order DE as being linear if it can be expressed in this fashion. Y prime plus, can you guys listen to my choice of words carefully? Plus some function solely in x times a nice clean y. Being equal to, I don't know, but some function solely in terms of variables. I'll call it q of x. I've got a DE that can be expressed in this form, I've got a new technique for you guys to use in solving this DE, but I'm a mathematician. This is not a physics class, this is not biology, it's not chemistry, I'm not gonna talk about laws, I'm gonna prove to you that my technique's gonna work. Matter of fact, I'll just cut to the chase. I'll derive this technique out of thin air. Let me get rid of this stuff. So I want to consider a DE like the one I just put on the board. And I want you guys, even though you might see why for the next 60 seconds, I want you to consider it. E raised to the p of x power. Actually, how about e raised to the integral of p of x with respect to x? And if I dive in and multiply both sides by that beast, here's what I get. I get the e raised to the integral of px dx times y prime plus px times e to the integral of px times y being equal to q of x times e to the integral of px. You guys humor me. Did I just multiply both sides by that thing? So I'll call it a factor. It involves integration. So if you guys don't mind, in English, I will often refer to this as an integrating factor. Now, it looks like I'm wasting your time in writing this in the inkboard, but if you look closely at the left-hand side, that left-hand side is absolutely slick. Because I think the left-hand side, as it's written, is nothing more than what you get if you differentiate with respect to x. The product of y with that integrating factor. Now, I am suspecting that you guys do not believe me, so it's time to take a break. I'll close my pen, and let's just walk backwards. If y is understood to be a function in x, to differentiate the product of two functions in x, I have to use a product rule. The product rule says this. Excuse me. To differentiate this product, you get the root of the first times the second as is. Oh, look at that. Plus the first as is, there it is, times the root of the second. But to differentiate e to some power, I just get e to that power. Well, chain rule says I better multiply by the root of the power, but the root of the integral of p of x with respect to x is just p of x. Oh, come on, nobody jumped. Isn't that slick? And now, in undoing the differentiation process, doesn't that tell me that y times e to the integral of px with respect to x is nothing more than the integral of q of x? E to that power? With respect to x. And I guess eventually what I'm really going to generate is some constant of integration. Meaning, of course, when I divide both sides by what's being multiplied to y, oh, look at this. My solution for y is a function in x is nothing more than e, the negative integral. Px with respect to x times the integral of my q of x times the integrating factor. And I'm integrating with respect to x. Plus my constant of integration times my e to the negative integral of p of x dx. That is slick. Look what I've just done, you guys. For a differential equation in this particular standard form, I have solved for y as a function of x, but there's one problem. Y is expressed in terms of some integrals. And I guess I don't get a closed form representation of this function unless I can actually integrate. I hope your Math 31 professor, your Calc 2 professor said at the end of the semester that we've lied to you this whole time. Gave you all these integration techniques, but technically speaking, outside that math classroom door, most integrals are not integrable in some closed hand fashion. And so sometimes I might come up with solutions that are expressed up to some integral which I cannot evaluate. So keep that in mind, because I'm being extremely, I'm slow with my words today, I'm sorry. Very general and abstract. And when you guys put this to use in another 30 seconds, you will see there's not nearly this much work. I'm not asking you to go that far. I think once you get to this position, slice piece of cake. So can I illustrate this whole new technique with an example? I'm not sure, because I didn't write everything down. It's a lot of times when I come to class, I make up examples just like that out of thin air. Help me with this. Does anybody know, because I thought the answer is yes. Didn't I create some slope fields with isopods with this DE? So one yes. I was hoping so. That's what I remembered. And so if you guys don't mind, can I go back to it? Because we weren't able to solve this DE prior to today. Now we can solve it. I maintain we can solve, for one.
Can you quickly explain
Yes, please.
the step in between, it looks like step 2 and step 3 there?
That was a big deal. I think that's where all the work is.
Yeah.
I want you to recognize that what's above the brace is indeed the derivative with respect to x of that product. So Bradley, let me walk you through this process. Let me walk backwards in case I made a mistake. To differentiate with respect to x, the product of two functions in x, you have to use a product rule.
Okay.
The product rule says, to differentiate this product, differentiate the first, oh there it is, times the second as is do not touch, oh there it is, plus the first as is, got it, times the derivative of the second. But to differentiate the second, I get e to the power right back, times the chain rule says the derivative of whatever the input is. But to differentiate the integral of p of x by x is just p of x. I'm trying to impress upon you that this really slick integrating factor, if I multiply both sides of my original DE by it, the left-hand side is nothing more than derivative with respect to x of the product of my solution with e to the power over there, which I call my integrating factor. You guys, this is just one integrating factor. There are many, many more you will not see in this book. Actually, there's another book outside the classroom, kind of a thick book, now, containing nothing more than various types of integrating factors that you multiply to both sides of DE if it holds a very specific form. This just happens to be an extremely common one that pops up more frequently than others.
What book is that?
I'm being silly, I don't know. But
You don't know, right.
I've found books out there with tables of integrals, or in this case, integrating factors.
Okay.
So you guys, let me dive into my first example. Where do I have enough room? Can I erase this? Since we're not really going to use it anyways. So you guys, I want you just to make sure I'm writing things down correctly. Is that a y prime equals x minus y? Is that correct? Yeah. What number is this? 3. Now I confess, it doesn't look like it's in this form over here. So if you guys don't mind, very briefly, can I massage it? So
Isn't that y prime?
Oh, thank you. My apologies. Now massaging it to look in standard form for first order linear. Can I get this? Give me the information. What's q of x? X. What's p of x? 1. To generate my integrating factor, I guess my integrating factor is simply going to be e to the integral of p of x dx. But that's just simply e to the x. Now I maintain, if I were to differentiate both sides by the integrating factor, I'm not going to write it. So I've already verified it's going to work in the general case. If I multiply both sides of my DE here with that integrating factor, I think on the left-hand side, what I'm going to end up with is nothing more than derivative with respect to x of the product of my solution with the integrating factor itself. Now, don't forget, I multiply both sides by the integrating factor. Am I not? Since it's my responsibility to find y in terms of x, I guess I better undo the differentiation process with respect to x on both sides of the DE. That means I get y times e to the x on the left-hand side, and on the right-hand side, I get the integral of x e to the x with respect to x. Oh, look at that. A Math 31 question. Piece of cake. We're Math 31 experts. They said, we're Math 31 experts. X e to the x minus
E to the x.
e to the x. See? Aren't you guys with me on this? It's just integration by parts in our heads, right?
I think I have something that you might need,
What's
but
that?
I'll bring it next week.
Okay. Now you make me nervous. Yes.
Here's how you went from like
And that's the biggest step. I think that's where all the work is. Now, I confess, I didn't write everything, but listen to my choice of words in English, and allow me to get away from this. I just maintain that if the DE really is in that really nice form, that new form I call linear, if I do make the proclamation that I of x is equal to this garbage, you check out what happens when I take this piece and multiply it to both sides of DE, both sides of that DE. I get this, but this is where I was arguing a moment ago, that what you see above this black brace is the result of differentiating the product. So, sir, when I went from second line here to, I'm sorry, I misspoke. When I went from second line here to third line here, I skipped a lot. I went from here to there. Now I'm just simply suggesting, since I proved this in a general setting, if I multiply both sides, the original DE by the integrating factor, the left-hand side really is the derivative with respect to x, that product. And that's why I wrote it in this fashion. I just want to shake my fist a little bit by saying, don't forget, you got this by multiplying the left-hand side by the integrating factor. That's not legal. Make sure you multiply the right-hand side by the integrating factor. Yes, sir.
When you integrate the integral of dx, if you have e to the integral of dx and you go to e dx, what happened to your c?
Oh, thank you. So two things to answer your question, because that's a really good one. I'm dumbfounded. I just walked right over that. Number one, I want n integrating factor. I just want one of them. But number two, if you don't listen to me, you give me all of them. If you put in here instead x plus c, isn't that the same thing as e to the x times e to the c? Isn't that e to the x times a? But like I said, I'm going to multiply both sides by the factor. I got a here and a here, factored out. It's over here. Oh, but wait a minute. I multiply this side by that thing, which has a factor of a as well. Now I divide both sides by a. It's gone. So do you see that? That's what gives you the right to say, I just want n integrating factor. Because even if I grab all of them, I get cancellation of whatever that coefficient in the end is. Maybe not a cancellation of the c, but eventually when I absorb it with the e, I get to cancel both sides by the a business.
So I see how
I should have mentioned that, I'm sorry.
when you get from line 2 to line 3 there, it looks like you integrated, right?
You know, I really did not.
You did not? All right.
I did not integrate because, technically speaking, I was simply saying that this is the process or the result of differentiating respect to x that product. I think that's very different.
How do you figure that out mathematically?
That's why I'm here today, because I'm saying, in general, I proved to you that this really does work. Well, I proved to you it works if the original DEs of this form.
Yes. But is there a way of mathematically figuring it out so I could do it?
Yeah, just follow my steps. That is the way to verify it, Brad.
All right.
I'm just saying in practice, you don't have to show me all the steps. I'm just saying in practice, since I've proven it to you in this general setting, which is why I'm leaving the board so you can attack me, that I get to make this jump from here to here.
Okay.
Anybody else, please? Your questions are too good.
So in problems involving this, are we going to be given the integrating factor?
No, good point.
We have to.
You're going to generate it, this is the way you can do it every time. Now, don't take this in the wrong way. Outside the math classroom, it might be the case you might not be able to actually integrate this thing.
Okay.
But I don't want to go there.
Okay.
Maybe just here and there a little bit, not much.
So the integrating factor always takes the form of e, the integral of whatever p of x is.
Yes, if your original DE was expressed in this form.
Linear. Okay.
I've got 4 minutes. Jeepers. How about this, you guys? I haven't finished. Now, it's not the case I can always express y as a function in x. It's not always the case I can isolate y in this equation, but you know what? In this example, I can. If I multiply both sides by e to the negative x, I simply get x minus 1 plus c times e to the negative x. And as a matter of fact, since I'm here in front of the classroom at the board, I might as well proclaim that y is indeed a function in x. I'll use the appropriate notation. Any other questions? All right. If not, you guys, I do not feel comfortable sending you home with this. Yes, sir.
I have a question. Can there be a function of x in front of the
absolutely. As a matter of, oh, you mean over here?
Yeah, where you wrote linear, 'cause I just remembered